right, so I'd like to start off with section 4.2. We're talking about trig functions. Of acute angles. And we say they've got to be acute angles because in order to use trig, what kind of triangles do they have to be used on? They got to be used on a right triangle. For now, anyway. All right. So, first of all, let me get my triangle up here. And I got to make sure I do a good triangle. All right. So here's what I want to do. I'm going to put my theta mark in this corner. So from theta, this side is going to be my opposite. What is this side next to theta called? Adjacent. Very good. And what is this wonderful side called? Hypotenuse. All right, now we're going to talk about those 6 wonderful trig functions. The first one is one you already know. That is sine. The sine of theta equals opposite over hypotenuse. Right? You know that from the beginning of SOHCAHTOA. The second one you already know is cosine, which is adjacent over hypotenuse. The third one, to finish out your SOHCAHTOA, is tangent. The tangent of theta is opposite over adjacent. All right, your 3 new ones. The opposite of sine is what we call cosecant theta. The cosecant of theta is hypotenuse over opposite. Secant, you think you did this? Hearing those words? Well, that's good. That makes me feel better. All right. So secant is the opposite of cosine or hypotenuse over adjacent. And the bottom one, the opposite of tangent, is what we call cotangent of theta, which is going to be adjacent over opposite. So once you've solved your triangle, you can find any of those ratios. It doesn't matter, right? Once you've found your triangle, or all 3 sides of your triangle, you can name them all. Oh, it's really not. It's more tedious than it is hard. Yes. Yeah. Right. What I'm going to end up doing is at some point I'll probably give you a note card that you can put these on. It's just kind of like a cheat sheet, make you feel comfortable. You probably won't even refer to it, but you'll have it there that you can use. Okay? Yeah, but the only thing that can go on there are like ratios and certain equations, okay? Like if you feel better having, I don't know, like the compound interest equation on there, I can do that, okay? All right, so now that we have those, here's how it works. Oops, I don't want to move it quite that far. If I have a triangle, so here's my triangle again. And let's say my triangle from this corner is 3, 4, and 5. I need to find my 6 trig ratios. So the very first one we're going to start with is the sine of theta equals, and from theta, opposite is 3, hypotenuse is 5. All right, we're good? The next one is cosine. Again, that one you already know. From the theta, the adjacent side is 4. The hypotenuse again is 5. Good. All right. Tangent of theta is from theta, opposite, which is 3, over adjacent, which is 4. So those 3 you've done before. Our 3 new ones. Cosecant of theta. So you can go from the theta and say it's hypotenuse over opposite, or it's the opposite of sine. You just flip sine over. Cosine. The opposite of cosine is secant. Secant then is hypotenuse over adjacent. Or again, you'll notice you flip over cosine. And cotangent of theta is adjacent over opposite. Or 4 over 3. So once you have that triangle there, the rest is easy, just to write them all down, right? Okay, so let's actually do an example similar to what you're going to get in the homework. All right, so here's example number 1. Depending on which problems I give you, this is actually covering 1 through 8. So we'll see where we go from here. It's going to give you or provide you with a triangle. In that triangle, it's probably going to put a theta in one of the corners. Could be this one. Let's put it up here. And they're probably going to give you information for 2 of the sides, and 2 of the sides only. So let's say we have 5 and 12. Well, we can't do our 6 trig functions until we have the third side, right? So how do we find it? A squared plus B squared equals C squared. So, first thing we have to do is the Pythagorean theorem. We have 5 squared plus 12 squared equals C squared. So 25 plus 144 equals C squared. Or 169 equals C squared, so C equals 13. All right. So now we're going to do our 6 trig functions. The first one is sine, the sine of theta. And again, you have to go to where your theta is. It is opposite over hypotenuse. Or in this case, 12 over 13. Cosine of theta. Where your theta is, yep. So I am always putting, you'll notice I'm putting my little marker right on the angle we're talking about, okay? So cosine of theta, the adjacent side to that is 5 over your hypotenuse of 13. Tangent from theta is opposite over adjacent, or 12 over 5. Now let's do our 3 new ones. Cosecant of theta, 13 over 12. Secant of theta, 13 over 5. And again, if you want to look to the triangle or if you want to look at cosine, it's up to you. Which makes more sense to you? And our last one is cotangent of theta is adjacent over opposite, or 5 over 12. So that doesn't sound bad at all, right? Okay, so I do have to make it a little bit harder, though. Okay? Everybody still good? Let's do example number 2. In example number 2, this is going to more apply to the 9 through 16, but part of it would also match up with the first section. In 9 through 16, it wants you to evaluate the 6 trig ratios, which again is what we were doing at the beginning. The difference is it's going to give you one of them to start. So if it says the sine of theta equals, how about 1/2? Whoops. Yeah, that's opposite hypotenuse. What I'm going to ask you to do, when all it does is give you that, is to sketch a triangle. So we're going to draw our triangle. All right, here's my triangle. I'm going to put a theta in one of the corners. Which one do I'm going to use? The bottom one. Okay, so I'm going to put it here. And from that angle, what I have is opposite, and I have hypotenuse. I need my third side, don't I, before I can do the rest of my trig ratios. So how do I do that? Pythagorean theorem, exactly. A squared plus b squared equals c squared. So we get 1 plus b squared equals 4. And subtracting 1 over, we get b squared equals 3. So b equals the square root of 3. And I need you to leave it as an exact answer. So it's got to stay the square root of 3. So this side is the square root of 3. Doesn't that sound like fun? All right. So now we're going to do the cosine of theta. Is adjacent over hypotenuse, or square root 3 over 2. Very good. The tangent of theta is opposite over adjacent, or 1 over the square root of 3. Uh-oh, what's wrong there? Gotta rationalize. How do we rationalize, Alyssa? Very good. So we're going to times both the top and bottom by the square root of 3. So our tangent becomes the square root of 3 over 3. We're still good? Okay. So now we're going to do the opposite of sine, which was cosecant of theta. Whether you go back to your triangle, it's hypotenuse over opposite, or you flip sine over, you get 2 over 1 or just 2. Very good. How about secant of theta? 2 over the square root of 3. So what do we have to do? Rationalize. Exactly. So we get 2 square root 3 over 3. And the last one we have is the cotangent of theta, which is adjacent over opposite, or square root 3 over 1, or just the square root of 3. So you're going to have to do a little rationalizing today too. Okay? But again, that's really good practice because, you know, it's one of those things you need to do all the time anyway, right? Okay, so far this isn't bad. All right. We're still doing good? Okay. So now, no, not quite. I want to go back and talk about our special right triangles and our trig functions. We're going to smash her all together. Okay? So our special right triangles we talked about the other day, we had 2 of them, right? One of them was this 45, 45. 45 degrees and 45 degrees, right? And remember that we always set this up as x, and this was x square root 2. The second one we had was 30, 60, 90. See if I can get that. There we go. All right. In the 30, 60, 90, the bigger angle is your 60. Skinnier one's your 30. And again, remember we said x was the short side. The long side was x square root 3, and the hypotenuse was 2x. Very good. All right. So using these, we're going to change this up a little bit. I'm going to tell you your hypotenuse is 1. Okay? So we're going to change these so every time you use this unit circle, it's the very smallest, not unit circle, every time you use these special right triangles, it's the very smallest triangle you can possibly have. Because we're going to say the hypotenuse is 1. All right? So I'm going to change this one up. My first triangle here for my 45, 45 is if my hypotenuse is 1, how do I figure out what my sides are? What did we do the other day to decide that? If x root 2 equals 1, set it equal to it, right? So we have x root 2 equals 1, dividing by root 2, so we have x equals 1 over root 2. So what are actually the sides to both of these? Yes, root 2 over 2. And whatever this side is, because it is isosceles, is also this one, root 2 over 2. Still doing good? Okay. Now, this was our 45-45 triangle. There is a radian measure that also means 45 degrees. What's the radian that represents that? So if we times by pi over 180 and leave our pi, how many times is 45 going to 180? 4. So this is the same as pi over 4. So now if I said your angle is pi over 4, it means the same exact thing, right? All right. And so before I do the other triangle, let's talk about this one. The reason I just did this is I want to know an exact answer. If I said, what is the sine at 45 degrees? You can look at that triangle. Go to 45 degrees. Opposite over hypotenuse. Yep, root 2 over 2. Technically over 1, but we don't care about that, right? What if I said to you, what is the tangent at pi over 4? So we go to pi over 4. Tangent is opposite over adjacent. What is our tangent at pi over 4? They're both the same. So if they're both the same, what do we get? 1, exactly. I'm going to write it here. Root 2 over 2 over root 2 over 2 equals 1. What if I said to you, what is the secant at 45 degrees? So again, remember secant from 45 is hypotenuse over adjacent. Oh my gosh, how am I going to simplify that one? Remember when you divide by a fraction, you multiply by it. Yeah, which means I would multiply by 2 over square root 2. Gets rid of this. And then I would have to rationalize, right? So I have to times by root 2 over 2. Or sorry, root 2 over root 2. And so what do we end up with an answer for the secant of 45 degrees? Root 2, exactly. Okay? So before I do the other triangle, in problems 19 through 24, they're looking for the exact answer for what's in your special right triangle. You're going to use this, and the other one I'm going to draw in a second. Okay? Are we all doing good? Actually, it's going to work for, 19 all the way through 27. So this is the rest of it. So let's do our other triangle. See if we can't figure that one out. Get my triangle in here. All right. So again, this was my 60 over here. This is my 30. If this side is 1, remember the short side is half the hypotenuse. So my short side would be 1/2. And then what is the long side? Half times square root 3, or we're going to write it as the square root of 3 over 2. You guys okay with that? All right. Now, I, of course, have to add a little fun to this. We added what kind of measure in the other triangle? We did a radian measure. Probably should put them in this one as well. So, the radian measure for 60 degrees. What is 180 divided by 60? 3. So this is pi over 3 in this corner. In the other corner, what's 180 divided by 30? So this corner is pi over 6. All right, so let's do a few more. This time I want to know, what is the sine at pi over 6? So you look at that triangle, find the pi over 6. From that angle, it is opposite over hypotenuse. So it's 1/2, exactly. Okay? How about if I said the cosine at 30 degrees? Oh, is it? Very good. It is square root 3 over 2. Because from 30 degrees, we do adjacent over hypotenuse, right? How about let's do cosecant of pi over 6. Cosecant is hypotenuse over opposite. So that's 1 over 1/2. Well, how does that simplify? Yep, times by 2 over 1, and we get 2. Correct. Okay, that's the last section. Now, this concept right here, using these two special right triangles with your hypotenuse being 1, is a majority of what this chapter is all about. Okay? So we're just introducing it. We're going to get into it. You are going to need to memorize these triangles eventually. Okay? Which I know you guys can handle. So, I would really like it. Let's change that assignment. Instead of odd, let's do multiples of 3. So it's 3 through 27. It's only 9 problems. Okay? 3 through 27 multiples of 3, because we're going to keep building on this anyway. You're going to get more repetition of the same stuff. All right?